regressions a couple times, and we need to just know the buttons for it. So I'm just posting a little video here so you can see the buttons, and also you can kind of see, hopefully I'm going to show you some of the ways that regression is useful. It does give you a way to create an equation for one thing, which is obviously useful, but there's also plenty of ways that you can use it just on your calculator that can be helpful. So here's some data here, the year and AIDS cases. It's very cheery. It's just some data I found. Okay, so I'm going to put it in. Now this is actually from a question where they tell you to try both. You can't see the question, but trust me that they tell you to try both linear and quadratic regression and to see which one fits best. And I'm going to show you sort of how entering data into your calculator, how you can work with it in a graph, and how you can see the data in a graph. You can create like a scatter plot sort of thing, and how that works. So it's up to you. Now, usually I would just enter in the years that are there, 1999, 2000, 2001, whatever. You could also, if you wanted to, you could count 1999 as like year 0 or year 1 and go like that. But doing it this way just kind of makes sure that you don't make any mistakes. Now, 4833, okay, 41, 289, 43, 171. So, okay, now this one, you'll always be told what type of regression it is. Is it linear? Is it exponential? Is it something else? Quadratic? There's tons of different types of regression that you could do on your calculator. Now, if this one, for instance, just told us it could be linear, it could be quadratic, and it wants us to pick, there is a way of telling. Now, there's a way that once you enter in this data, your calculator can graph this data for you as like a scatter plot. And the way that you do that is you go up here. I'm just going to clear this out because it's old. Turn on plot 1, so just highlight it and press enter. Okay, now if I graph, those points are going to show up, but of course you have to think about what the x values were here. It was the x values were 1999, 2000, 2001. The y values are 41,000. So I need to change my window, so I'm actually going to be able to see that. So if I change this to 1998, let's just say, just 1 year less, the maximum to 2010, let's say. And I'm just going to go up by 1 because that's not very much. Because x scale is how much you go up by. So 1998 to 2010, that's only 12. So I can easily go up by 1s there. Now my lowest y looks like, it's over 40,000. So I'm just going to go 40,000. Okay, my highest y, I'm just going to pick like 50,000. To give myself some space. Now, obviously, I don't want to go up by 1s there because I go from 40 to 50,000. That's 10,000 difference. So I might want to go up by 500 or something. You could pick 1,000. It wouldn't be wrong. It's fine either way. Now, when I graph this, look, you can see these dots, okay, from my plot. Now, this regression is not going to be perfect either way, okay, but I can see the plots there. I can see that that's not linear. I would probably say it's quadratic would fit at least slightly better. So I'm going to go into my stat. Okay. Now, when I want to do a quadratic regression, or any type of regression, I go over into Calc, and I can see all my different types of regression are here. So 4 is linear, 5 is quadratic, 6 is cubic, 7 is quartic, 8 is another linear. I'm not really sure why there's 2. Maybe someone can find the answer for me. 9 is logarithmic. 0 there is exponential, and that's the type that we were looking at today. But anyway, I'm thinking this is probably quadratic, so I'm going to pick 5. Okay, now if I want to make this go automatically into my graph, okay, what I can do is press variables, y variables, and I can just use that function right there. And that will make it go right away. Okay, there is a shortcut for that. I just looked it up. Okay, so the shortcut for that is if you want to just do the shortcut, it's alpha F4 and there's Y1 right there. So that means I can put that into my Y1. I can put that into my graph. Okay, now it gives me the equation here. So if I wanted to write down the equation, I could. Okay, so it gives it to me ax squared plus bx plus c. It gives me the 3 variables. But because I stored it, it automatically goes into there, and I can look at it on my graph. I can see how it fits. It fits fairly well. It's sort of like a line of best fit situation, right? Where I can actually look at that. You know, if I want to work with it though, I want to turn off this plot. Okay, now if this regression was actually accurate and we were saying like we're using it to estimate something, I could use this to estimate value. So I could use it to estimate something like how many cases will there be in 2005. I would hit trace 2005, and it would tell me it thinks that there's going to be, if it follows this regression, there will be about 47,876 cases. Okay, so let's look at the one we saw today in class. Okay, here is some data. This is, it doesn't tell you what it is, but there's years in population, so it's some kind of population growth. Okay, so I go into my stat edit. Now, if I have stuff in these already, what I do is I go up to L2, I press clear and down. Don't press delete. Okay, do not press delete, because that will make the column disappear, and it'll be a pain. You'll have to reset it. So again, I just enter this data in. I make sure I don't make any mistakes. Oh, so far I'm making lots of mistakes. 1998, 1999. This is a fun video, just me entering things in the calculator. Okay, 2000, 2001. And there was a question that went with this one that asked, what will the population be in 2010, assuming it follows this pattern. We're told it's an exponential regression, so we know exactly which one to use, but we'll take a look at it and just see if we could tell it anyway, just looking at it. So this 2003, okay, and then I go over to here, and it's 276.1. Okay, 279.3. Sorry, my keyboard on this thing is a little iffy. 282.4, 285. And you really don't want to make any mistakes, because if you do, obviously your information is not correct, your data is not correct, so your regression will not be correct.
Excuse the interruption. Could I have all grade 11 students to the rock training, please?
These are pretty short. In 30-2, they have to do some that are like 30 long. They're brutal. So the ones we see will all be pretty short. So this is an exponential regression, we think, anyway. Now, again, if I want to check... Oh, my gosh, look at that. That's still messed up. So I'm going to go and fix that. I think I could have figured it out by now. Oh. God. Oh, jeez. My goodness. So I messed up, so I have to go back into my list. Okay, and that should be 1998. God only knows why I could get that right. Okay, so that looks pretty good. Now, again, if I want to look at that on my graph, if I want to look at the points, you don't always want to, but if you did want to, you turn on the plot. Now, again, you'd have to change your window to make it pretty reasonable here. My years are pretty good, actually, because that's what I wanted. But these values, my y values, aren't very good. I have to look over at my y values in my table. They're all about 270 to 300, so that's what I'll go. I'll go start at 270, and I will go to 350, let's say. Or actually, maybe, well, we'll just see how it goes. We'll see how that looks. And now maybe I want to go up by 10. So I don't want to go up by 500 anymore because that's way too much. Okay, and if I look at this plot, okay, there it is. Okay, and that doesn't look that exponential, but we're trusting that it is. It looks kind of like it could be linear, but we're told to do an exponential regression, so that's what we're going to do. Okay, so I go over to calc, okay, and I go down to, and I keep going forever, down, down, down. Okay, exponential regression. Okay, and again, in store, I want to store it. Oops. I want to store it in my y1 because that will allow me to graph it. Okay, and if I do that and go calculate, it'll give me the equation, but I don't need to write it down because it's already in my calculator, so why would I write it down? Okay, it'll give me this nice equation there. That's the same one I got on the board today, so it must be right. Okay, and if I graph this to take a look at it, okay, you can see it goes through those points really nicely, really, really nice. Okay, so it must be right. Okay, that's a beautiful line of best fit. And now if I want to work with this, if I try right away, if I'm like, okay, it's a 2010, so I'm going to just trace 2010, you see it brings me out. That's because I can't work with this function when my scatter plot's turned on. So you might not even want to turn it on, but I just wanted to show you how it looks. So when I graph it here, now if I want to figure out what the population is in 2010, okay, sorry, this is very slow today. And if I want to see what my population is in 2010, I would just press trace 2010. So trace 2010. Enter. That allows me to check any x value I want. So it looks like 313.3. That's what it would be following that same pattern. You could check 2008, 2009. You could check 2050 if you wanted to, but you'd have to change your windows. Okay, it's very straightforward. Now, if you wanted to figure out, like, when is the population going to reach 300? Okay, if you wanted to do something like that, you would have to go into your y equals. You would make a second graph with 300. And then you would graph it. And we're trying to figure out where they cross. So I would press second calc, intersect number 5, okay, and just enter, enter, enter. And it tells me 2005.8. So just towards the end of 2005 is when our population would be over 300. Okay, so that's how you do that.